Hello, I think that we can start. Probably more people will be joining us, but I think that we are ready. And so welcome to the webinar led by Jim Staley, Senior Vice President at Positron Access. Hello, Jim.
Hello, nice to meet you all.
I would like to inform all of you that the session is being recorded and we will share the video of the session within a few days after the webinar. So if you have any questions during the session, you can write them on chat. Jim will check it by the end or during the session and reply to all of them. So Jim, you can start.
Thank you very much. I'm pleased to be here with all of you. I've been in the broadband industry now for 25 plus years, doing everything from fiber to wireless to DSL, coaxial applications. And this presentation will be about how to light up multi-dwelling unit, multi-tenant unit subscribers without the cost, the mess, and the extra time of rewiring. So that's what this presentation is about. Wincom is a new partner of Positron, and we're very proud to be part of their product line. So between Wincom and Positron, we'll try to teach you something new this morning, and please ask questions via the chat, and we'll collect all the questions at the end, and I'll try to answer them for everybody. All right, first thing. If you're wondering whether you're at the right place, if you're here to learn how to provide your multi-dwelling unit customers super high-speed broadband without rewiring, yes, you're in the right place. And we applaud all broadband service providers who have put the copper, fiber, wireless facilities in their network in order to get as much bandwidth as possible to each building. And with single-family homes and small businesses and so forth, it's pretty easy to get that fiber inside and all the way to the subscriber. But we also understand the difficulty of extending that bandwidth inside brownfield, multi-tenant business units or multi-dwelling apartments, condos, townhomes, schools, hospitals, barracks, you name it. Our specialty is helping you with getting high speed inside the building, but without having to drill through concrete, steel, without having to mess with a historical building, without having to deal with asbestos, no rewiring. That's what we specialize in. But what's inside these buildings makes it a challenge, right? It's going to be copper, telephony, twisted pair, or it's going to be coax, or it's going to be both. So we built a platform that specializes in the use of that copper twisted pair and coax. The Positron product we'll talk about today that Wincom now stocks, builds bill of materials, does application engineering for, is called the GAN, the G.hn Access Multiplexer. It uses a technology called G.hn, and it extends the power of your fiber inside throughout a brownfield multi-dwelling unit or multi-tenant unit. So the presentation consists of a little bit about who we are. You already know who Wincom is. You're probably a Wincom customer or have used some Wincom supplies before. Agnieszka can tell you all about that. We'll talk about the G.hn technology that's utilized in our platform to allow us to avoid that rewiring. We'll talk about why to use it and where, because it's not everywhere. Obviously, if there's already fiber inside the building, if there's Cat6 inside a building, you don't need us. You may need other Wincom products, but not us. We'll talk about the situations where you would need us, talk about the solution family, sort of the family portrait, the application examples, software integration, partners like Wincom. We have technology partners and software partners, as well as Wincom to stock and distribute our product. And of course, then at the end, we'll make sure to take questions for you. Positron has been doing business globally from North America with headquarters both in the United States and in Montreal, Canada for 50 years. We've specialized in helping telcos, cable companies, utilities, cooperatives, enterprise clients from small to medium to large improve their networks in terms of power safety, and in terms of telecom and broadband speeds. That's what we do. This particular product we're bringing to the market now is brand new and very innovative, and it's gotten some awards for being innovative, and the inventor of the product, Pierre Trudeau, who's our president and CTO, has also been honored in the industry for bringing this product to market. It's a brand new product that solves a very difficult problem, and that is the number of brownfield buildings around the world that haven't yet been rewired. So let's talk about the technology first that takes care of this problem for us. It's called G.hn. It's an ITU standard. It's the G.9660 standard in the Gigabit Home Networking Forum. And it's had multiple evolutions of chipsets, just like BPON to GPON to XGS-PON, for example. We've had wave 1, wave 2, we're going to wave 3 in a year and a half. Wave 2 provides 2 gigabit service, basically 2 gigabit PHY rate, 1.7 gigabit pure rate that can be used upstream or downstream within buildings over copper twisted pair or coax to provide super high speed dynamic service. That is dynamic in that it switches between upstream and downstream faster than a customer can do a speed test. We have an evolutionary path towards a 10 gig solution on coax and a 5 gig solution on copper. Right now, symmetric gigabit is our strength. And then when we get to multi-gig services, we'll be going to the wave 3 chipset. Positron has worked to invest significant resources to improve the standard G.hn chipset and make sure that it is dynamic, make sure that the vector boost works, make sure that it's paired with a non-blocking Ethernet switch, because essentially what G.hn becomes is the meat in the middle of an Ethernet sandwich. You got Ethernet coming in, we take it, convert it to G.hn, propagate it throughout a building, and convert it back to Ethernet. So we're very standards-based. We're just a media converter in the middle using a specialized technology in order to get super high speeds over long distances on those older Cat3 copper twisted pair facilities or the RG59 coaxial facilities. We've also worked very hard with a number of technology partners, which we'll highlight in this presentation, to make ourselves, for those fiber networks, to make ourselves a multi-port ONT on major vendors' XGS-PON platforms, to make ourselves a partner for Wi-Fi access points, to make ourselves a partner for wireless backhaul. For example, Cambium, Ciclu, Tarana, all the others work with us, drop Ethernet to us so that we can take it inside buildings. Folks like Calix and Nokia and DZS are working with us on XGS-PON OMCI so that they can run a GAM from their OLT. So those are the kinds of work that we've done. And it works because XGS-PON is a platform, a standards-based platform, and it works because G.hn is a standards-based platform as well. Let's take a look at the rate reach of this phenomenal technology that you can now bring inside your buildings. Our copper twisted pair multiplexer is called a GAM-M for MIMO. It's MIMO because it supports either single pair, SISO, or multiple pair, multiple input, multiple output, in order to get greater speeds over Cat3 over longer distances inside buildings. It can obviously work on anything that's twisted pair. Cat3 is the one we did the testing on, and Cat4, Cat5, Cat6 and up provide better speeds. We wanted to provide a baseline for the traditional brownfield copper twisted pair. And that baseline includes the blue line, which is SISO, single pair, where you see the star out there at about 150 meters for the ability to provision gigabit service. Then the green line is for MIMO. That uses multiple pairs, 2 pairs to be exact, in a single port. We don't burn an extra port. You just put 2 pairs in a single port on our multiplexer, and you can now get up to 250 meters or more with gigabit service. So that's how the copper twisted pair solution works. I'll show you obviously a picture of the multiplexer shortly. For coax, we go even further because it's a great insulator conductor. And that means on RG59, the basic one, you can get 300 plus meters. On RG6, you can get 700 meters plus. And on RG11, you can get 1,000 meters plus of gigabit service through our facilities. So why would you use the GAM and where? What makes sense? Well, there's a lot of MDU, MTU deployment challenges in the world. Bringing fiber to each door in a single family home or a small business is pretty easy. You drill a hole, you fish it through, you find the right place to put it, you turn everything up, and now you're 100% fiber end to end. That's great. We applaud you for doing that. But when you get to a multi-dwelling unit, particularly one that's brownfield and it's got a lot of nooks and crannies, got a lot of concrete, maybe steel, glass, it's more difficult. And there are regulatory issues. There's the cost, time, and mess of it. And then there's profitability and payback that are challenges in this MDU marketplace. So where you would use us is to overcome regulatory issues. Regulatory issues are different in each country. I know how they work pretty well in North America, and now I know how they work in Australia. We've done some business down there. Every country in Europe will have some rules around whether they're encouraging competition inside multi-dwelling units. Are the facilities, the copper, the coax, the fiber inside the building owned by the landlord or the service provider? Those are important questions to ask and answer, because if the facilities are owned by the landlord, if competition is encouraged, then you'll want to make a very careful study of that structure before taking fiber to every unit or before taking Cat6 to every unit, because we eliminate the cost, the time, and the mess of doing that. These complexities, the time needed to rewire, the costs of doing it, and the fact that you're probably going to try to do it for 100% of the building. You're not going to do one wiring job a day as each subscriber turns over to your service. You're probably going to try to do the whole building in anticipation of a pretty high take rate if you're competing, or perhaps you've done a deal where you've won 100% of the building and you're going to serve the entire building instead of the traditional service providers, or because you're one of the traditional service providers. So again, it's a lot of different directions that can be taken here. You have to know the rules in your particular environment. You have to know what your profitability and payback period are going to be if you wire out the entire building versus putting a single multiplexer in, winning your subscriber, moving their copper or coax over to our GAM, and then getting revenue for that subscriber. That's what we do. We shorten the payback period because you don't need to roll trucks. You don't need to rewire. You simply put the GAM in, use the facilities inside the building, take them from another service provider and put them on yours because you're better, you're faster, you're more competitive, and immediately your business case can be calculated. So the GAM has a number of qualities that help you solve all those challenges around cost, time, and mess, and regulation, and so forth. First, we meet broadband expectations. Those expectations are low latency for gaming, high speeds for streaming, no pixelation on their video, work at home, school at home, Internet of Things. The GAM meets these requirements with up to symmetric gig service. We leverage the existing brownfield MDU wiring, so we improve your time to market. We improve your return on investment of the service provider, the install hours. There's no construction, there's no mess, and you minimize the needed take rate to become profitable. We differentiate services with a scalable solution that reduces churn. We increase the real estate values for the property owners of any one of these properties. They can advertise symmetric gigabit services, and therefore renters or buyers of condominiums or townhomes will be more likely to move into that building. We, of course, for the service provider, ensure that we focus on return on investment, total cost of ownership, reduction of capital expenditures, and so forth. The markets that you would use it in are, it's not a brand new building that already has Cat6 or fiber. It's an existing building, whether it's garden style, mid-rise, or high-rise, that's brownfield and difficult to rewire, or maybe it's not so difficult to rewire. You're still going to want to compare the cost of rewiring with the cost of a symmetric gigabit G.hn solution from Positron and Wincom. We also made sure that we used all components that are MEF compliant. We're great for business. That means mixed use environments with residential and business. We're there for you. Corporate campuses, enterprise applications. We're in all sorts of businesses providing this service today, just as if they had fiber to the unit. Resorts and hospitality is another big business for us as hotels came out. The hotel industry came out of COVID after years of not great profit. They didn't want to remodel all their rooms, but they wanted to provide better guest entertainment services where they could. And most of the time they had old facilities, sometimes copper twisted pair, but most of the time coax. They're using the GAM to upgrade their guest experience without tearing out drywall and fishing new wires through their building. This is the unit itself. Just wanted to reiterate a few key things. It shows you a one rack unit GAM for coax on top with 24 ports. Those come in 24 or 12 ports, standard F-type connectors. And then on the bottom, it shows a 12-port SISO MIMO copper twisted pair unit, comes in 12 or 24 ports. Both devices, it should be noted, are agnostic with respect to what kind of bandwidth you bring to them, up to 10 gig, as you can see, 2 10 gig slots for a standards-based SFP+. That same slot, of course, can be used for a special ONT on a stick, which interfaces with today Calix and later Nokia, DZS, and other XGS PON vendors. So you can feed it as a multi-port ONT from an XGS PON, but you can also drop Ethernet into it from an Ethernet switch or from a wireless backhaul radio, active optics, you name it. That's an all-purpose 10 gigabit slot for bringing bandwidth into our multiplexer. The multiplexer is built with not only the G.hn capability, but also a non-blocking Ethernet switch. That means that all the bandwidth coming to us from each G.hn port, whether it's an F-type connector, as you can see on top, or an RJ45 or RJ11 connector on the bottom there, every ounce of bandwidth comes through the GAM and it gets converted to Ethernet and pushed back out on the 10 gig ports for the backhaul. So it's good for small, medium, and large applications. I've shown you the indoor stackable solution here on the first slide, and now I'm going to show you the hardened solutions and smaller solutions in the product family on the next slide. So this is the product family. On the left-hand side of those indoor rack mount GAMs, 12-port and 24-port for coax and copper that I've shown you already. In the middle is our outdoor hardened IP68 GAM. It comes in 4 and 8-port models for coax and copper twisted pair. So whether you need a hardened solution or whether you need a slightly smaller solution, that's the device for you. And it allows mounting on the wall, inside pedestals. It's submersible for a certain period of time based on its IP68. It's very compact, as you can see on this slide. Once you've selected the GAM for a particular application based on the size of it, the type of it, the environmentals, then we also have endpoints that connect to it. I mentioned what we do is we take Ethernet in, we're the G.hn in the middle, and then we take Ethernet out as well. So these endpoints that you see on the right-hand side are specifically to convert that G.hn back into Ethernet and hand it off to a residential gateway or another radio or an Ethernet switch, anything that's standards-based Ethernet. We work with lots of partners, of course. Every Wi-Fi residential gateway we'll work with. We work with the more sophisticated Wi-Fi access points for managed Wi-Fi, Ruckus, Aruba, Meraki, Cambium, for example. So just about anything goes. And whether it's coax or copper twisted pair, we have multiple options. We've got standard media converter. You can see about 10 options there on the far right of the screen. We've got a standard media converter. We've got reverse power in case the GAM itself doesn't have power. You can power it back from the unit, whether it's on coax or copper twisted pair. We've got models that again are for sophisticated Wi-Fi access points with thousands of VLANs and multiple Ethernet ports. We've got models that do PoE, both Wi-Fi 5 and Wi-Fi 6, both 15 watts and 30 watt PoE supported today, with plans for 60 watt in the future, as some of our service provider customers want us to not only take bandwidth from radio, but also provide it with power. So that's the entire product family provided to you by Positron and Wincom. I want to show you a few simple application slides so that you can get an idea of how it works inside these buildings and throughout the transport network. So each of these application slides shows the data center on the left. That's where the internet, that's where the broadband is coming from, whether it's over fiber facilities or wireless facilities, doesn't matter to us, as long, again, as you use that 10 gig SFP slot with any amount of bandwidth you want to give it. We've got 100 megabit cable modem serving us in a small motel in Dalton, Georgia, but we've got tier 1 service providers providing us with 10 gig active optics, so that anything in between is fine. Bring that to the GAM. As you can see here, we have 4 GAM 24Ms. What does that mean? 24 ports times 4, 96 endpoints, 96 subscribers on Cat3 copper twisted pair inside the building. So we take the bandwidth from, again, the radio or the GPON device or the active optics. We convert it to G.hn. The yellow lines represent the G.hn going throughout the building to each unit. At each unit, you'll have an endpoint that takes that G.hn and converts it back and forth between G.hn and Ethernet and hands it over to a residential gateway or a Wi-Fi access point. So it's that simple. And every one of those subscribers could be provisioned with symmetric gigabit. So that's a copper twisted pair application. Notice 4 shelves, 4 times 24, 96 subscribers. Then you've got the outdoor hardened units that are smaller for those garden style apartments and so forth. This slide shows a similar application, except for there's 2 buildings. They're each served by GAM. They're each fed transport, and they each utilize the reverse power endpoint. And by doing so, they eliminate the need to be fed with electrical power, except from the endpoint. Each endpoint supports a single subscriber on a single port, and that means any one of them can turn off their power without affecting the operation of everyone else's internet inside that building. I want to show you coaxial applications as well. And there's some additional feature benefit when you use coax. Not only does it go longer distance, but if you've got that inside the building and you can use it, keep in mind that we support splitters. So that means instead of as in the copper twisted pair application, a single port provides service to a single endpoint and a single subscriber. In the coaxial environment, a single port can provide service to up to 16 endpoints, 16 subscribers. A single GAM, whether it's a 12 or a 24, supports up to 120 subscribers. Because of the processor and memory, we can go up to 120. That means where we showed you 4 shelves serving 96 subscribers in this slide, we're showing a single shelf serving 120 subscribers in this slide. That's because you can mix and match and split any way you want on any port, as long as you don't exceed the 120 subscribers. And each of those endpoints is managed by the GAM, whether it's 1 per port or 16 per port. And again, the rate limits and the VLANs and the priority queues are all managed by the GAM, by the Ethernet switch inside the GAM, to ensure that this feels a lot like an Ethernet switch with a web GUI, as well as a Cisco-like craft interface port to do the management. Just like with the copper, we've got small units that are for smaller applications or indoor applications and or outdoor hardened applications. And this you see is a GAM4 application, 2 buildings. Each building could have up to 64 subscribers because those 4 ports can each support 16 endpoints 16 subscribers. And in this case, we're using reverse power again. On those ports, at least one subscriber has the premium reverse power endpoint, the CR, and that allows that port to be powered. So keep in mind, I'm not going to show you, we can do a more personalized presentation where we show you dozens of applications, applications that suit your needs. The GAM is not just a box, it's a complete network solution. So ask us about daisy chain configurations. When you're going throughout campuses, we can feed from one GAM to another using GAM ports for transport and distribution. Ask about PoE. I mentioned PoE. We do PoE where you plug it in and power one additional device. We do PoE where we inject power and you don't have to plug it in and still power another device. Talk to us about gaming applications. Wireless applications add a lot of latency. We don't add latency. We're microsecond latency. You can stack our boxes on top of each other and still provide excellent gaming. For IP TV, we support it. For streaming, we support it. On coax, we support cohabitation of additional video channels as long as they're in certain video RF spectrums. We can add those to the data that we're providing. We use 5 to 200 megahertz. Outside of that, you can add broadcast video from rooftop, satellite, dish, DirecTV. If you want to get rid of VDSL2 and you want to do it in a phased fashion, we can talk to you about a migration plan to remove DSL technologies and replace them with the better G.hn technology. I've mentioned XGS-PON a number of times. If you use a major vendor's XGS-PON, ask us about the software, the OMCI work we're doing with that particular vendor and the GAM to make us simply a multi-port ONT on their XGS-PON OLT. Our partners have great try and buy programs so you can verify the performance for yourselves. That's usually the first question I get is, okay, it's hard for me to believe. I want a MIMO system, or I want a coaxial system. I want to bench test it, and then I want to take it to the field and use it. If it performs as you say it does, you can work with Wincom on that, and Positron will help Wincom to ensure you get those try and buy systems. So let's talk about partners and some software and subscriber management for just a moment. GAM solutions are enabled so that we provide the software that you need no matter what your model is for your back office. If your model is manage each device with its own system, we got it. We've got both the craft interface port, we've got a web GUI for you. It's free of charge, no extra charge. And every GAM can manage all subscribers, all endpoints from that GAM through a command line or through a web GUI. So that's great. But if you use your own back office and you like to customize and bring everything to the same screen, we've got JSON and SNMP compatibility. We got APIs and documentation. That's also free of charge. In addition, for some customers that don't have their own back office but want to manage all their GAMs because they've got lots of MDUs from a single window, we're building an EMS called Virtuoso. So it's multi-GAM. It manages it the same way as a web GUI, but it manages all the GAMs, allows you to select one GAM from hundreds of GAMs in your network, build a picture of that network, and select the GAM and manage all the subscribers in it. There will be a per subscriber fee, a per port fee for Virtuoso once it's available in early 2024. And then I mentioned partners. If you've got some inventory and billing partners like RGNets or ETI or Sonar or somebody else, bring them to us, bring them to Wincom so that we can do integration work with them. RGNets, ETI, Sonar are already completed, but we know there are others out there, and we're willing to work with you, with your partners. Calix is our first XGS-PON OMCI partner, but there's more in the works, including Nokia and DZS and so forth. So we'll work with you on that as well. This is what the GUI looks like in any one of our GAMs. You can see the unit itself. You have access to it. You have diagnostics for each port. You can do service monitoring. You can configure all the services, whether it's rate limits, priority queues, VLANs, etc., all through our GUI, also through the craft interface, which looks pretty much like you're provisioning a Cisco or Juniper or anybody's router. So we're just about to the question and answer section of this this session. But in summary, before we get there, the Positron GAM provides accelerated service delivery combined with significant cost savings for our service providers, eliminate the cost, the disruption, the inconvenience of messy rewiring projects inside these brownfield buildings, and inadequate legacy technologies around coax or copper that we replace. And by doing so, eliminate churn, keep your customers, keep them happy, keep them from moving out. That's what we do. We extend the reach of your fixed wireless or fiber transport without expensive construction projects right into the building, eliminate the permits, eliminate the new AC drops, electrical drops, or costly asbestos removal by using the GAM, and exceed the desires, the needs, the expectations of your broadband subscribers with respect to speed, simplicity, and reliability. So that's the end of the standard presentation material. If there are questions, I'll take them now. Agnieszka, did anybody ask any questions, or does anybody have any questions at this time for me? Or for
we don't have any questions for now, so this is the moment that you can write down your questions on chat. In the meantime, I will inform you that after the session, I will send you the video recording of the session and also contact details to Jim. So you can contact directly Jim, or you can contact our team to get more information. Also, Jim, maybe this is also a good idea if we have here UK customers, UK partners, to invite them to visit our booth, where we will be next week together with Positron Access and also Cambium Networks at Connected Britain Show. This will be booth number 4848A, but you will find us by the name, of course. Still, we don't have any questions, so I think that we can finish for today. Thank you very much for the presentation, Jim. Thank you all for your participation, and we will stay in touch.
Yeah, thanks for your time this morning. Make sure and funnel all your questions through to Agnieszka so she can get the right WinCom team member to set up and schedule webinar, a personalized webinar with WinCom and Positron. We'll help you out.
Exactly. Thank you, Jim.
Thanks, everybody. Appreciate your time.
Bye. Goodbye.
Thank you.